to my YouTube channel, The Concepts of ICT. From this lesson, we are going to begin a new lesson series on logic gates. The last lesson series was number systems. If you want to learn about number systems, the conversions between number systems, you can go and watch my previous lessons. Okay, so in this lesson, as I told you, we are going to learn about the logic gates. When we are discussing about logic gates, there are a few things that we need to know. What is a logic gate? How do we represent them? What is the functionality of a logic gate? And how we represent that functionality. So, a logic gate basically is a simple circuit that provides or creates an output according to a given input or a set of inputs. So when we discuss about logic gates, there are two types of logic gates. They are the basic logic gates and combinational logic gates. So in this lesson we are going to discuss about the basic logic gates, the functionalities about them, and how we represent them. So when we discuss about the basic logic gates, there are three basic logic gates. We call them AND, OR, NOT. Those are the names of the basic three logic gates. So these three are the basic logic gates that we are using in our logic circuits. So as I previously told you, you should be able to identify each logic gate. So there's a particular symbol for each logic gate to identify logic gate in a circuit. This is the symbol of AND gate. And it is a symbol of the OR gate. And that is the NOT gate. So when we get a symbol, the left side of the main symbol is called the inputs, and this is output. Inputs, output. Input and output. So in every logic gate or a logic circuit, we should be able to express its functionality using a particular expression or a formula. For that, we are going to use variables. A variable is simply, here it is a letter. Variable is something where the value can vary between some range. In logic circuits or logic gates, a variable can vary among 0 and 1. The value can be either 0 or 1. So here we are going to represent the variables as A and B. For now, let's represent the output as F. So what are these AND or NOT gates? First, let's see what is the meaning of the word AND. Let's take an example. You say to a person that you need a pen and a pencil. What does that mean? That means you need both of them. You need the pen and you need the pencil as well. But if you say that you need a pen or a pencil, that means you need at least a pen or a pencil. If you have both, it is a good thing, but you don't need both. So the same concept is used in these logic gates as well. AND means you need both the inputs to generate an output. Or on the other hand, it means you need only a single input in order to generate the output. I told you previously that the values these logic gates get, or the variables, the values of the variables are 0 or 1. 1 in these digital circuits means there is an input. 0 means there is no input provided. So the functionality of a logic circuit is logic circuit or a logic gate is expressed using a particular formula. For that we need to know the formula or the expression of each logic gate. The expression of AND gate is made using the dot. You put a dot between the inputs provided to the AND gate. So in this example, the inputs are A and B. So what we do is we put a dot between A and B. So we write the output as A dot B. Okay. For an OR gate, you put plus in between the inputs provided to the gate. So here the inputs are A and B, so the output will be A plus B. So this NOT gate. The functionality of a NOT gate is, what it does is, it inverts the input provided. If it gets 1, it converts that into a 0. If it gets a 0, it converts that into a 1. That is what it does. So we represent that by a overbar or a dash. So you write it as A bar. That is the input provided to that gate. A is the input, so the output is A bar. And again, the functionality of a logic gate or a circuit can be represented using a concept called a truth table. A truth table simply contains all the input combinations or all the input values for the variables against its respective output. So it shows what is the output that is going to provide if the certain input set is provided to that logic gate or the logic circuit. You can even create truth tables for logic circuits. Okay, let's see that. In truth tables, the values, the variables can get, here the first value can be 0, A's first value, and B's first value also can be 0. A's first value can be 0 while B is 1. A can be 1 while B is 0. A can be 1 while B also is 1. So the output will be, as we discussed, the both inputs should be 1 in order to get 1 as the output. So the first combination, 0 and 0, the output will be 0. 0, 1, still 0. Because we need both inputs to be 1. 1, 0, 0, 1, 1. That the output will be 1. Because both the inputs have provided some value. So the output will be 1. So if we try to create the truth table for OR gate, let's see how it will look like. Okay, as we discussed previously, in OR gate, to get 1 as the output, we need at least one input to be the value 1. So in this first location, both inputs are 0. So the output will be simply 0. 0, 1. B is 1. So the output will be, so it has provided a value to the gate. So there will be an output. The output will be 1. Here also 1. And the last one, last combination, 1, 1. So it is okay. You have both inputs. So the output still will be 1. In NOT gate, there is only a single input and output. The value will be, A can be either 0 or 1. So when you provide a 0 to a NOT gate, what will you get? It will be simply inverted. So if the input is 0, you will get 1. If the input is 1, then you will get 0. Okay, that is all about the basic logic gates. So that is what we are going to learn in this first lesson. So we learned what is a logic gate, what are the functionalities of logic gates, what are the two types of logic gates, and we discussed about the basic logic gates. There are 3 basic logic gates, AND, OR, and NOT gate. So we discussed the functionalities of each of these gates. We represented the functionality of these gates using an expression, and even we displayed the functionality using the truth table. So hope you learned the basic concepts about logic gates, and hope you liked the video. Please subscribe for more videos on the concepts of ICT. Thank you.